Hello student, my name is Mr. B.K. Gotekar, working as the assistant professor in Department of Chemistry, KTHM College, Nashik. I have taught course CH102 Organic Chemistry for semester 3 for FIBC class. In today's lecture, we are going to discuss the topic that is the inductive effect. That is one of the structural effect. So inductive effect, before that, you must know what is the polar and what is the non-polar molecules. So non-polar molecules, when you consider the homoatomic molecules like H2, also like Cl2, like Br2. So all these homoatomic molecules are non-polar molecules. So why this is non-polar? Because in these molecules, electron pair, here electron pair is present, here electron pair is present. This electron pair is equally shared by the two atoms. So here this electron pair equally shared. So these molecules are homoatomic and non-polar molecules. Polar molecules, suppose HCl, HBr, HI. So this polar molecule is nothing but heteroatomic molecules. Here two different atoms is present. One is the hydrogen, other is the chlorine. Same way hydrogen, bromine, hydrogen and iodine. So here electron pair that is present between two atoms is not equally shared here. Why not equally shared? Because here two different atoms is present. Out of two different atoms, one is a more electronegative, one is a less electronegative. So here chlorine is a more electronegative. So this electron pair is slightly towards the chlorine atom. Slightly towards the chlorine atoms. So here because of that, electron density around the chlorine atom is increases here. So because of that, this chlorine acquires the negative charge here. Okay, partial negative charge. Why? Because electron pair is not equally shared here because of chlorine is a more electronegative. And when chlorine is a more electronegative, electron pair is slightly towards the chlorine atom. So this chlorine atom acquires the partial negative charge. So we write here delta negative. Same way we write for this hydrogen, because of this hydrogen acquires the partial positive charge. So we write like that. Same way for this HBr molecule also. Here bromine is the more electronegative than hydrogen. So this bromine acquires the partial negative charge. Because here also electron pair is not equally shared. Here electron pair is slightly towards the bromine atom here also. Like this we write. So here this atom acquires the partial negative charge. So we write here delta negative. And here we write the delta positive. Same way we can write for this molecule also HI. So when you compare between the hydrogen and iodine atom, iodine is the more electronegative. So we write here delta negative, this is delta positive. Okay. So all these heteroatomic molecules are polar molecules. So this polar molecules show this kind of polarization. So this kind of polarization is not present in non-polar molecules. So suppose if same concept we consider in organic molecules, suppose I take the example of methyl bromide here. Okay. So when you write the same, like here, this molecule, hydrogen bromide, sorry, methyl bromide molecule. So here carbon and bromine, between these two bond is present. Electronegativity of carbon and hydrogen is same. But here carbon is a more electropositive, bromine is a more electronegative. Means there is a difference between the electronegativity of carbon and bromine. So because of that, when we consider that here, the electron pair between carbon and bromine here not equally shared. Not equally shared. So electron pair means bonding electron pair. This slightly move towards the bromine atom here. Okay, because of bromine is a more electronegative, and because of that, this bromine acquire the which charge? Partial negative charge. So this acquire the partial negative charge, while same time this carbon acquire the partial positive charge like this here. So this again we can say this methyl bromide molecule is a polar molecules. So same concept when you write in terms of, suppose this carbon is further attached to carbon. Suppose I am writing the example of like this here, CH3, CH2, CH2 and CH2. So when you consider the example of N-propyl bromide, so in N-propyl bromide also we can say here, suppose this is a carbon number 1, this is a carbon, suppose this is a carbon number 1 here, this is carbon number 2 and this is carbon number 3. So in N-propyl bromide, we can say that here the carbon number 1, C1 carbon and C1 and Br bond. This bond is a polar bond. So why this is a polar bond? Because you know very well bromine is a more electronegative as compared to the carbon. So bromine acquire the partial negative charge. So over bromine we can write the partial negative charge delta negative. Same way, so this is a polar bond. So because of this polar bond, this carbon acquire the partial positive charge. Why? Because this is a polar bond. So electron pair is not equally shared here. Electron pair is slightly toward the bromine atom. So the electron pair is not equally shared. And because of that, we can write delta negative and this write the delta positive. But here, because of this here, as this C1Br bond is a polar bond, because of this bond, the bond between C1 and C2 also, this also become polar. How? Because here, because of this electron pair between the C1 and C2 bond, means between the C1 and C2 bond, between these two electron pair is present, this is also not equally shared. Why? Because of bromine. So this is not equally shared, and because of that, this carbon number 2, is also acquire the partial positive charge. So for our convenience, suppose I am writing here, this is the delta 2, this is the delta 1. So this electron pair means electron pair between carbon number 1 and carbon number 2. This is not also equally shared. So because of this, carbon number 2 acquire the again positive charge, that is the partial positive charge, while this also already partial positive charge like this. And because of this, also remember that because of this bond become polar, again bond between C3 and C2 carbon, this bond also become partially, this again become polar bond. So why? Because here also electron pair is not equally shared, and when not equally shared, this carbon also again acquire the delta partial positive charge like this we write here. So electron pair is not equally shared also between these two. So what we write here? Delta 3, delta 2 and delta 1. So when you compare between these charges, we can say that this delta 1 have the higher magnitude as compared to the delta 2 have the higher magnitude as compared to the delta 3. So we can say that C1Br bond is a polar. Because of this polar bond, this bond is also become polar. Means because of C1Br bond between C1 and C2 carbon also become polar. And so because of this, the C3 and C2 bond, this bond also become polar. So here, when you compare the partial positive charge, this have the higher magnitude as compared to delta 2 as compared to delta 3. Okay, this is the magnitude. So what we can say from this? So actually here polarization present in one bond. Actually polarization present in one bond means actually polarization present in this bond actually. Actually here polarization present in CBr bond, but this polarization are induced in adjacent bond. And this is nothing but inductive effect. What I am saying, this is nothing but inductive effect because here polarization present in bond CBr, but that polarization induce the polarization in adjacent bond. So that polarization induced in adjacent bond is nothing but inductive effect. So how we can define the inductive effect? We can define the inductive effect in this way. It is the polarization induced in adjacent bond because of polarization present in one bond is nothing but inductive effect. So what we say? We can say that polarization induced in adjacent bond due to polarization present in one bond is nothing but inductive effect. Here we can say that polarization present in one bond, that is a CBr bond, that polarization induced in adjacent bond, that is nothing but inductive effect. So definition of inductive effect is nothing but the polarization polarization present in one bond induce the polarization in adjacent bond is, is known as inductive effect. Polarization present in one bond induce the polarization in adjacent bond is nothing but inductive effect. So we will going to discuss here some important feature of this inductive effect here. Inductive effect, important features. First important thing is that here this inductive effect present in ground state of the molecule. So in heteroatomic molecule, heteroatomic molecule, in ground state, in heteroatomic molecule in ground state, this effect is present. This is the first feature. Next is the permanent effect in molecule. This is a permanent effect present in the organic molecule. Particularly, this effect is present in the organic molecule, permanent effect, and heteroatomic molecule means polar molecule. This effect is present in ground state, and magnitude of this effect is very small. Remember, third silent feature is that magnitude is small. Magnitude of this effect is very small. This is the third important feature of this, third important silent feature of this inductive effect. Next is the type of inductive effect. There are two types of inductive effect, plus I and minus I. Plus I means electron donating inductive effect. Minus I means electron withdrawing inductive effect. So depending upon direction of pulling the electron, we can divide the inductive effect plus I and minus I. So in plus I inductive effect, when atoms or group of atoms increase the electron density around the carbon atoms, that time we can call plus I inductive effect. Plus I means electron donating inductive effect. When atoms or group of atoms that withdraw the electron or that decrease the electron density around the carbon atom, we can say minus I inductive effect. So in plus I, atoms or group of atoms increase the electron density around the carbon atoms. Here, atoms or group of atoms decrease the electron density around the carbon atoms. So here, which factor affect the plus I and which factor affect the minus I? We are going to discuss here. So first factor. So when you compare the suppose two groups here, so here oxygen, this is negatively charged oxygen, this is the neutral oxygen, and this oxygen has the two electron pair. So which group show the more plus I effect? So this oxygen increase the electron density around the carbon atom. This oxygen also increase the electron density around the carbon atom. So this group show the plus I effect, no doubt. But negatively charged oxygen have the more plus I effect than neutral oxygen atom. So always remember, negatively charged atoms have the more plus I effect than neutral atoms. This is the general rule about the plus I effect. Okay. So same way we can write for the minus I. Like this. So here, this is the heteroatomic molecule. Nitrogen is more polar than carbon. So this is a polar bond. And when this is a polar bond, here there is a minus I effect, there is a inductive effect. So nitrogen shows the minus I effect. Here is also nitrogen, but this is a positively charged nitrogen. So we show the more plus, this show the minus I effect. Minus I means this atom decrease the electron density around the carbon. So here when you compare between these two, so positively charge atom have the more minus I field than neutral atom. So this group means here this nitrogen, this positively charged atoms or group have the more minus I field than neutral atom. This is the first rule regarding the minus I field. Second rule here, suppose if you consider there two groups here, methyl magnesium halide, and here this is a boron compound. So when you compare between these two, this group is a more, means when you compare between the magnesium and boron, magnesium is a more electropositive, more electropositive. Okay, while this boron is a electronegative, so less electropositive as compared to the magnesium, less electropositive. So this is a more electropositive atom, magnesium, which is attached to carbon. Here boron is a less electropositive when you compare between the magnesium and boron. So which atom should the more plus I field? The atom which is the more electropositive, that should the more plus I field. So here this show the, means magnesium show the more plus I field as compared to the boron. So magnesium show more, means that have the more or that have the large plus I field as compared to the boron. This is the second rule for the plus I field. In case of minus I field, so when you consider these two molecules, methyl fluoride and methyl iodide, so fluorine, you know very well, one of the most electronegative elements in the periodic table. So fluorine show the, so this is a more electronegative, most electronegative, we can say most electronegative element, and compared with fluorine, this is the less electronegative. So which show the more minus I field. So obviously we can say this atom, that is the fluorine, that show the more minus I field. Means fluorine have the more minus I field or more large minus I field as compared to iodine. Okay. So next is the third, that is the, suppose I am consider the example of alkyl group. So in case of alkyl group, here there is ethyl group. Suppose here this is the isopropyl group, and here this is tertiary group, and suppose this carbon further attached to any carbon. Suppose here there is the one alkyl group, here again, sorry, here over this carbon, this is one alkyl group, over this carbon one, and this is just two alkyl group, here 1, 2 and 3. Okay, so we can say that which group has the more plus I field. So here there are 3 alkyl groups, here only 2, here only 1. So when you consider this groups, here more alkyl group, 1, 2, 3, here only 2, here only 1. So as number of alkyl group increases, plus I field is also goes on increasing. Means here this group show the more plus effect as compared to the other groups. So more alpha group, more plus effect. And here, as number of halogen atoms increases, minus effect is also increases. Same way, suppose I am writing here methyl fluoride CH2F2, CHF3 and CpF4. So we can say that order is like this. CF4 molecule, 4 fluorine, so more means here most minus effect we can observe in this molecule. Here 3 fluorine minus effect is decreased here as compared to the CF4. Here 2 further decrease and here further decrease because of only one fluorine atom. So in this way you can say that these are the some factors that affect the plus I and minus I. First is the neutral atom and negatively charged. Here positively charged and neutral atom. Here second factor about the electropositive character. As more electropositive character, more plus I effect. As more electronegative character, more minus I effect. Okay. Third factor about the number of alpha group. As number of alpha group increases, minus I effect is plus I effect is increased. As number of fluorine atom is increases, as number of electronegative atom increases, minus I effect is increases. And last is the last factor, that is the percentage of S character. Difference between the plus sign and minus sign. That is the percentage of S character. As percentage of S character increase, plus I field decrease. This is the last. And also in case of minus I, we can see that in opposite way we can see as percentage of S character increases, minus I field increase. Minus I effect increase. Okay. So we will come with example. Suppose here in alkyne, percentage of S character is almost 50%. Okay. So in alkyne molecule, large minus I field we can observe. Large minus I field means this atom means this carbon is sp hybridized. Sp hybridized. So this carbon exerts show the large minus I field. So what we say? This atom show the large minus I field because percentage of S character. This carbon is sp hybridized. Here the carbon is a sp2 hybridized. Percentage of S character is almost 33.33%. So here as compared to alkyne, minus I field is less. But here observe the small minus I field. Small minus I effect. Here in alkane molecule, carbon is a sp3 and percentage of S character only 25%. How much? 25. So here no minus I effect. No minus I effect. But this sp3 hybridized carbon show the plus I field show electron donating inductive field. Show the plus I field. So in this way we can say plus I and minus I. Percentage of S character increases, minus I field is increased, but plus I field is decreased. So this is all about the how inductive effect is present in case of percentage of S character. So in this lecture, what we discuss? We have discussed that firstly, what is the polar, what is the non-polar molecule, how in polar molecules this inductive field is present. Inductive field is nothing but polarization induced in adjacent bond due to polarization present in one bond is nothing but inductive field. So how in polar molecule this inductive field is present, we have discussed. Also we have discussed some silent feature of this inductive field. Also we have discussed the which atoms show the plus I field, which atoms show the minus I field, with distinguish between the plus I and minus I field. We have discussed all the things about the inductive effect.